My name is Matthew Julian. I am in Dr. Tien's heat transfer class, and this semester we have been working on an active heat sink project. Initially, we started with a bare heat sink and attached thermocouples to it. We started off with verifying Newton's law of cooling, and towards the end of the semester, we have actually used a blower to verify the heat transfer coefficient, or to find the heat transfer coefficient when you have forced convection. We go in and we find the variables that we're going to need and the equations we need. This will allow us to figure out what kind of data and information we need to find through the lab. And we put the heat sink on a hot plate and we bring it up to temperature, up to steady state. And we also had a blower and a pitted tube that we set up in between the fins. We start collecting data to verify that the heatsink has come to steady state, and we turned on the blower, and the pitted tube measured the velocity, and we actually watched the decay in temperature as the heat transfer coefficient increased. The pitted tube recorded the velocity, which allows us to calculate the heat transfer coefficient using correlations that we learn in class. You can calculate the heat transfer coefficient just using or knowing the heat that has been applied, but in this particular experiment, we're going to compare that with calculating the heat transfer coefficient using correlations that we've learned in class. So once the blower is on, we have actually gone from natural convection and air. We turn on the blower, and then we actually are using forced convection. So with that increased heat transfer coefficient, we're going to see a decay in the actual surface temperature on the heatsink, which is recorded by our thermocouples. We actually had 8 thermocouples set up so we can actually see the distribution along the surface moving up to the tip of the fin. To start with, we actually made a shroud that would be attached to the front of the blower that allowed us to bring the blower straight up to the heat sink itself. One thing that we did notice and we verified is we took the velocity measurement right coming out of the shroud at the very face of where it butted up to the heat sink. And we also took the velocity at the back of the heat sink after the air had passed through, and we looked at the average velocity at both of those points because the velocity may change as it goes through there. Well, I think it was more to verify. Taking it from the front, you could actually see if you had turbulent flow coming out of the shroud, or if you're in the boundary layer. So due to the shroud, but our velocity was fairly uniform from front to back. We did see a little bit more of a fluctuation at the front, a small fluctuation. The standard deviation of the velocity values that we were getting over time fluctuated a little more than they did at the back, which kind of told us that we might have a little bit of turbulence coming off of the shroud. The conclusion that we get using our correlations is probably going to be a little bit more, I can say, accurate than using Newton's law of cooling. That's what I expect to see. Yes, our next step is going to be to take the data that we've recorded from the thermocouples that is hooked up to the heatsink, and we will go ahead and calculate the heat transfer coefficient using Newton's law of cooling directly. And we will compare that against the results. Compare that against the results that we obtained from using the velocity and the correlations we learned in class, Reynolds number, Prandtl's number, and see the difference between those two methods of calculating the heat transfer coefficient. So I think this semester, having the opportunity to work in this lab and work on this active heat sink project in a group, I think that it was just a great opportunity. It gave us an opportunity to get hands-on experience and hands-on learning of the stuff we're learning in class. And I really feel like it really reinforced these things that we learn in class. And it's a big difference of learning something out of a textbook than it is to get that hands-on experience and actually taking this data and getting these results from it and seeing this firsthand.